now we would be doing the example number 1 of the complex number. So here we have given that the two complex numbers which are in the question are equal, and we have to find out x and y which are real values. So we know that if two complex numbers are equal, then the real part of the complex number 1 is equal to the real part of the complex number 2. And in the same way, if the complex numbers are equal, then the imaginary part of complex number 1 is equal to the imaginary part of the complex number 2. So we write it as RE of Z1 is equal to RE of Z2. I would write it in the further notation. So here I am writing it briefly so you could understand it more clearly. So now it is RE of Z1 is equal to RE of Z2, which is real part of complex number 1 is equal to the real part of complex number 2. And in the same way, the imaginary part of complex number 1 is equal to the imaginary part of the complex number 2. And these two things are very much important. You have to mainly take care of in the first example, that whenever this case occurs, these properties are always applied to the complex numbers. So after this, when we see the question over there, so they are already given that both the complex numbers are equal. So by the above statement, we can simply find out the equations, like we can directly take out the real parts of the complex numbers and the uh, imaginary parts separately. So we're gonna take the equations. So which is the first equation we're gonna take is from 4x plus I bracket 3x minus y equals to 3 plus I minus 6. So first equation would be 4x equals to 3. Mark it as the number 1 equation. So we got the real part now. So we have to get the imaginary part now. So that is 3x minus y is equal to minus 6. So mark it as the second equation. Now I'll clear this so I could explain you more. So here I'll write down the equation. So 4x equals to 3, and so I'll mark it as 1 for your easy convention. So 1. So after 3x minus y equals to minus 6. So here we got the two equations. So we would be taking out x value from the equation number 1 and would be substituting it in the equation number 2. So it's an easy method of substitution. If the equation is so complicated, then we use another methods. But here the easy method is that we get the value of x and put it over in the value of, like, in the equation number 2. So from equation number 3, we get the x value. So I'm going to put it in the equation number 2. That is, like, after putting it, it becomes 3x minus y equals to 6. Minus 6 is already given. So after putting it, 3x in the place of x, I will put 3 by 4. So that is 9 by 4 minus y equals to minus 6. So as I'm writing, 3x minus y equals to minus 6. So it implies 3 into 3 by 4 for easy understanding minus y equals to minus 6. That implies 9 by 4 minus y equals to minus 6. And that implies 9 minus 4y equals to minus 24. I have sent the under 4, I have took LCM, then I have sent it to the other side. So 9 minus 4y is equal to minus 24. So minus 4y equals to minus 24. Now in the next step, I would be taking out the 4. So y equals to minus 33 by minus 4. So here we got the y value and x value. So if you cut if we take out the both minus signs, we will get 33 by 4. That implies that we got our answer, that is x equals to 3 by 4 and y equals to 33 by 4. So I would be placing the second link, second example link on the I button over here, top right corner. Join the Telegram link for further more.